Good evening, everyone. Today we will going to see the JEE PYQs from our chapter Solutions, and this is the first part. Okay. Until now, we have covered our solution theories and its NCRT exemplar and the CBSE PYQs, right? So today we will going to see JEE PYQs for the solution chapter. This is the part one of the series. So let's start. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using the generative AI, which is experimental. Okay. So let's start our first question. This is the MCQ question from our NCRT section 1.2 under the chapter in the chapter solutions. So the question asked that a molar solution is one that contains 1 mole of a solute in. So question is asking that if you talk about a molar solution, okay, 1 molar solution or a molar solution, what that molar solution define is that it is the solution which contains 1 mole of solute in what? Okay, so if you have to write the definition for 1 molar solution, it will contain 1 mole of solute in what? Okay, that you have to tell. So first of all, let me clarify that we are talking about molar. That means molality. So by that, you can relate this question and answer it. So the given options, the 4 given options for this question are 1000 gram of the solvent, 1 liter of the solvent, 1 liter of the solution, or 22.4 liter of solution. Okay, so basically, you have given 4 options, 4 choices of different amount of solvent, right? In grams and liters, you have given different amount of solvent. You have to fit that amount or the correct amount in the given question to give the correct answer for this question. Okay, so you have some time to go through it. After that, we will continue to its correct answer. Okay, so let's see the answer. Okay, so for the given question, the correct answer is option A, which is 1000 gram of solvent. Okay, so in a molar solution, we talk about 1 mole of solute in 1000 gram of solvent. If you explain it using the concept 7 point, if you explain using the concept 7.10, we know that molality is equals to moles of the solute which is present in 1 kg of the solvent, right? You know that molality is represented by small m, okay? And its formula is given by the number of moles of solute, the number of moles of solute divided by the weight of the solvent, okay? So weight of solvent, and it is the weight of solvent should be particularly in the kg units. Okay, so this is the formula for the molality represented by small m. A number of solute is fine. You can determine it by using the given mass upon the molar mass for the solute. But the weight of solvent should be present in our kg. If it is given in grams, you have to convert it into kg, or in any other unit, you have to convert it into kg and then you have to put here. Okay, so the moles of solute present in 1 kg of solvent will be defined as 1 molar solution, right? So kg, the 1 kg is equals to the 1000 grams. It is just unit conversion, So 1 kg contains the 1000 grams. So you can also write it here as number of solute divided by the weight of solvent in the 1000 grams. Okay. So basically, the molar solution is the one solution that contains 1 mole of solute in 1000 gram of solvent. This is the definition for defining 1 molar solution. Okay, for 1 molar solution, the number of solute should be 1 and the weight of solvent should also be 1 kg, or you can say 1000 grams. Okay. That is why our correct answer is option A, that 1000 gram of solvent. Okay. Okay, moving on to the next question. Okay, so this is the question from the NCRT section 1.2 in the chapter solutions. The question asks that the molarity, which is represented by capital M, of an aqueous solution which is containing 5.85 grams of sodium chloride in the 500 milliliter water is. So what you have to identify, or you have to determine the molarity of an aqueous solution. And in the aqueous solution, you have the sodium chloride, which is 5.85 grams, and the volume of the solution is given as 500 milliliter water. Okay, so the given quantity is the molar mass of sodium, which is 23, and the chlorine, which is 35.5 gram per mole. Okay, this is the molar mass for the uh, sodium and the chlorine separate. Okay, just you have to identify that what will be the molarity of an aqueous solution in which the solvent is water and the solute is sodium chloride. Its weight is given and the volume of the water is also. Their molar masses respectively is also given. Okay. Okay. So this question has been into the 2024 mains exam, and the options given for solving this question are 4, 0.2, 2, or 20. Okay, so you have some time, go through this, solve it, and then we will see that what will be the correct answer. Okay, let's see. So for the given question, the correct answer is option B, that is 0.2. That means the molarity is coming out as 0.2. Let's see how. Using the concept 7.1, the given amount or the given quantity are, we have given the mass of sodium chloride, which is 5.85 gram. It is given, right? That the mass you are taking to dissolve in the aqueous solution is 5.85 grams of sodium chloride, or you can say salt. Okay. So the volume of water is also given, which is 500 ml. You can write it as 0.5 liters. We just convert the milliliter to the liters. Okay, by dividing this quantity in the milliliter by 1000. Okay, so when you the given quantity of can say water is 500 milliliter, you have to convert it first of all into the liters by dividing it to the 1000. Why we are converting it into the liters? Because in the molarity formula, first of all, in this question we are asking about the molarity, right? And in the molarity formula, we use the volume, especially in the liters units. Okay, we want our volume in the liters units. So the volume of water will be 0.5 liter. Now we simply use the molarity equation or formula, which is given by the fraction of number of moles of sodium chloride, which is our solute, divided by the volume of the solution in the liters specifically. This is the equation 1.8 given in our NCRT, and the molarity is defined by this formula. We can determine the number of moles of sodium chloride. We have its given mass. So basically, the number of moles of any solute or substance, you can determine it by its given mass divided by the molar mass. Right. Now, the given mass for the sodium chloride, is 5.85. So you just put it here, 5.85, and you divide it by the molar mass of the sodium chloride. Now, how can you determine the molar mass? You just have to sum the molar masses for sodium and chlorine. So 23 plus 35.5, right? So basically this you have to do, and after solving this fraction, you get the number of moles of sodium, right? Volume of solution you have given, and we just converted it to the liters, which is 0.5 liter. So the molarity you can define as 5.85, which is the given mass, divided by the molar mass, which is 23 plus 35.5, which is equals to 58.5, and divided by 0.5. 0.5 is the liters, 0.5 liter is the volume of the solution. When you solve this fraction, this 5.85 will come in the denominator, and or you can also simplify this 5.85 upon 58.5, okay, by just replacing the decimal, and then you can solve this fraction, and the molarity finally is coming out as equals to 0.2 molar. Okay, so this is the final value of molarity, and hence our correct answer is option B, which is 0.2. Okay, let's move on to the next question. Okay, this next question is also from the NCRT section 1.2 in the solutions chapter. And the question asks that if a substance A dissolves in the solution of mixture B and C with their respective number of moles as Na, Nb, and Nc. What it is saying, that we have a substance which we are representing it by A. We are dissolving this into the solution of a mixture of B and C with their respective, and they have their respective number of moles. Like the substance A has number of moles Na. The mixture containing B and C, the B number of moles is Nb, and the C number of moles is Nc. The mole fraction of C in the solution is, you have to tell that what will be the mole fraction of C in the solution. Okay, so we are talking about mole fraction first of all. Okay, where we talk about the moles ratio of solute and the solvent. And in the question, we are saying that we are taking a substance A, which we are dissolving into the mixture of B and C, and they have their respective number of moles, which are represented by Na, Nb, and Nc. You just have to tell the mole fraction of C, which is present in the solution. So this question has been into the 2024 mains examination, and the given 4 options for this question are Nc upon Na times Nb times Nc. That means the number of moles of C divided by the product of the number of moles of all the components like A, B, and C. Or the number of moles of C divided by the number of mole of A minus number of mole of B minus number of mole of C. Or the number of mole of C divided by sum of number of moles of A, B, and C. Or number of moles of B divided by number of mole of A plus number of mole of B. So these are the 4 choices. You have to identify that which will be the correct answer, which will be the correct mole fraction for the C in the solution. Okay, so you have some time, go through it. After that, we will see what will be the correct answer. Okay, let's see. So for the given question, the correct answer is option C, which is number of moles of C divided by the sum of number of moles of all the components A, B, and C. Now, let's see, using the concept 7.7, the mole fraction the formula or the definition of the mole fraction is defined as the fraction of number of moles of the component divided by the total number of moles of all the components. This is equation 1.4 given in our NCRT book, textbook. So the mole fraction is defined by the fraction of the number of mole of component for whatever component we are determining the number of moles. So it's mole fraction. So if we are like in this question we are asking about the mole fraction of C. Okay, so the mole fraction of C, okay, the mole fraction symbol is chi. We represent the mole fraction by chi, and as we are asking the mole fraction of C, so chi C. Okay, so the mole fraction of C will be equals to the total number of moles of the component. That means the total number of moles of C divided by total number of moles of all the components. That means N for A plus B plus C. Okay, all the number of moles which is present inside our solution for all the components, that sum will be in our denominator. So this is the correct formula or representation for the mole fraction for our component C. Okay, so this is the formula. Now from the above definition of the mole fraction, the mole fraction of C will be, you have to determine the mole fraction of C only. So the mole fraction of C, you can write it as NC, that is number of moles of C, divided by the sum of total number of moles of all the components. So Na plus Nb plus Nc. Okay. So in the question initially given that we are adding substance A into the mixture, and in the mixture B and C are already present, and you have to tell the mole fraction of C which is present in the mixture. So it is simply just the number of moles of component, that is we are asking about component C. So Nc divided by the total number of moles of all the components which is present in our solution. And after the mixing of A into the mixture, the total number of moles will be Na plus Nb plus Nc. We have to add the number of moles of A also, right? So this will be the equation for the mole fraction. This is also, you can find it in the 1.5 equation in the NCRT textbook. So Na and Nb and Nc in this formula is representing the number of moles of our substance A, B and C. Hence, the C option is the correct answer as it representing the correct mole fraction of the component C. Okay, moving on to the next question. Okay, so this question is also from the NCRT section 1.2 in the solutions chapter, and the question asks that the quantity which changes with the temperature. So you have to identify a quantity, a term which change with the temperature. That means when you change the temperature, the quantity will also change. So this question has been into the 2024 mains examination, and the given four options are molality, mole fraction, mass percentage, or molarity. So you have some time, go through it. After that, we will continue to the correct answer. Okay, so let's see. So for this given question, the correct answer is option D, which is molarity. Now, so using the concept 7.2, let's see the concentration terms. Concentration terms means the terms in which we use the concentration of the solution to define that. Okay, to define that term. So the concentration terms such as mass percentage, mole fraction, and molality, they are independent of temperature. Okay, in the mass percent, which we talk about the mass. Mass is a constant term; it will never change. Okay, in the mole fraction, we talk about number of moles. Number of moles is also the concentration term. That means it will not depend on the temperature directly. And the molality has also no relation with the temperature as it defined as the number of moles of solute upon the weight of solvent. Right. So weight, mass, it will not depend on the temperature. So the mass percentage, mole fraction, and molality concentration terms are independent of temperature. They will not depend on the temperature. However, molarity is a function of temperature, and since it depends on the total volume of the solution, so molarity is a function of temperature. Why is it so? Because molarity is the number of moles of solute divided by the volume of the solution. Okay. Now, volume is a factor which depends upon the temperature because it will change with the change of the temperature. Right? That means volume of the solution will change with the temperature. If you change the temperature of solution, the volume will also change. So molarity is a function of temperature. That means molarity changes with the temperature because it depends upon the total volume of the solution. So, as I said, molarity is defined as the moles of solute divided by the volume of the solution. This is the equation 1.8 given in our NCERT textbook in the chapter solution. So, this is the formula for the definition of, for the defining of molarity term. And you can clearly see the volume is given here, which is temperature dependent, changes with the temperature. That's why molarity is a function of temperature. Okay. And the question asks that which quantity change with temperature. So, the correct answer is option D, which is molarity. Okay. So let's move to the next question. Okay. Now this question is also from the NCERT section 1.2 in the chapter solutions. And the question asks that the mole fraction of a solvent in the aqueous solution of a solute is 0.8. The molality in the mole per kg of the aqueous solution is. So the mole fraction of a solvent for a solute is given as 0.8. The molality you have to tell for that solution in the moles per kg units. Okay, so this question has been into our 2019 means examination. And for this question, the given four options are 13.88 times 10 to the power minus 2, 13.88 times 10 to the power minus 1, 13.88 or 13.88 times 10 to the power minus 3. So you have to tell the molality of the aqueous solution. Mole fraction is given for the solute, right? You have given four choices. So you have some time, go through it, think about it, try to solve it, and then we will solve it together and see the correct answer. Okay, let's see. So for this given question, the correct answer is option C, which is 13.88. Now using the concept 7.7, the number of, or you can say the mole fraction of solvent we have given as 0.8. Okay. You know this relation which we have taken from the NCERT 1.7 equation, which is mole fraction of the solute and the mole fraction of solvent sum, or you can say the sum of mole fraction of solute and solvent is equals to the 1. Okay. And we have already given the mole fraction of the solvent, which is 0.8. Okay. So, the mole fraction, we have just see that the mole fraction sum for the solute and solvent is 1. And the molar mass for the one, that means the our solute or our solvent is 18 gram per mole. We are talking about the aqueous solution. That means we are talking about the water. Okay. We are considering here the aqueous solution as water. And the molar mass for the water or the molar mass for the solvent is 18 grams. How? You have the formula H2O for the water, right? So if you tell the molar mass, it will be 2 times 1 plus 8 times 2 means 16. Okay, and 16 plus 2 will be 18. So 18 gram per mole is the molar mass for the water molecule. So the molar mass of the solvent is 18 Now, what it means? It means that we have the mole fraction of the solvent as 0.8. So, by using this equation 1.7, you can tell that the mole fraction of solute, that is Chi2, will be 0.2. 1 minus 0.8 will be 0.2, right? You just have to take this mole fraction of solvent term here into the right hand side, and the sign will change from positive, it will turn into the negative. So 1 minus 0.8 is 0.2. That means the mole fraction of solute will be 0.2. Now we just use simply the molality formula because we have to determine the molality. Molality is defined by the mole fraction of the solute divided by the mole fraction of the solvent multiply by 1000 divided by the molar mass of the solvent. Okay, this is we just transform it from the molality real formula. So the molality is defined as the number of moles of solute divided by the weight of solvent in the kg. You know that, right? Now, number of moles will be given mass upon molar mass, and the weight is already present in the kg. If it is not in kg, as then you have to multiply it by the 1000 because in the mole fraction we, you know, we take, like, we have to tell the molality in the kgs. So for the uh, for the molality we have to multiply this term by 1000. That means we have to convert the grams into the kilograms because the molar mass of the water is given in the grams, 18 grams per mole. Okay, so the number of moles divided by weight of the solvent, this is the molality, and you can also write it as given mass upon molar mass multiplied by 1000 because the weight, the molar mass of the solvent is not in the kg. So we just multiply it by 1000 because you can directly convert it also. Like from 18, you can directly convert it and then you can put into the formula. And from here, we derive the formula for the molality, which is given as the number of the mole fraction of the solute multiplied by 1000 for the unit conversion divided by the mole fraction of solvent multiplied by the molar mass of the solvent. Okay. Now, when we have everything, we have chi2, we have chi1, we have m1. You just have to put the values here in this formula. So the chi2 is 0.2, right? So 0.2 multiplied by 1000 divided by 0.8, which is chi1, multiplied by 18. 18 is the molar mass for the solvent. And when you solve this fraction, so 0.2, 0.8 decimal will cancel out and it will be 1000 upon 4 times 18. And when you solve this fraction, it will be 13.88 mole per kg in the specific kg units for the molality. Okay. So this will be the correct answer after solving all this solution. So hence the correct answer is our option C, which is 13.88. Okay, so this is the correct molality. Okay. Moving on to the next question. This question is also from the NCERT section 1.2 in the chapter solutions. And the question asks that what would be the molality of 20% mass by mass aqueous solution of sodium iodide, Ki? Potassium iodide, Ki. Okay. So we have to identify here the molality for a solution, which is 20% mass by mass for the potassium iodide. We have also given the molar mass of potassium iodide, which is 166 gram per moles. This is the given molar mass for the potassium iodide. Okay, so you have to identify the molality. This question has been into the 2019 means examination. The 4 options given for solving this question are 1.48, 1.51, 1.35, or 1.08. So just think about this question. You have some time and try to solve it, and then we will see the correct answer. Okay. Let's see the correct answer. So for this given question, the correct answer is option B, which is 1.51. Now, using the concept 7.7, the molality of 20% mass by mass aqueous solution of potassium iodide can be calculated by using the formula. Okay, so we are talking here the mass by mass ratio. Okay, mass by mass ratio, that means 20% mass by mass means some 20 grams of mass in some mass of the solution. Okay, we are talking about like that. So you have to tell the molality for this type of 20% mass by mass aqueous solution of potassium iodide. And we use the formula, which is molality is given by W2 upon M2 into 1000 upon W1. This is the equation 1.9 from the NCERT textbook. This is just simply the derivation, you can say, like molality is defined as the number of moles of solute upon the weight of solvent in the kg. Right? So number of moles of solute will be, you can write it as given mass upon the molar mass, right? Let's suppose given mass is W2. 2 we are representing. W2 is for the solute, W1 is for solvent. Okay. So W2 divided by its molar mass, that is M2, and divided by the weight of the solvent, that is W1 in the kgs. Okay. If not, it is if it is not in kg, we have to divide it by the 1000. So we have to just divide it by the 1000. So this W1 first of all go in the denominator, or you can also say this M2 will come here, and it will be W2 upon M2 into W1, right? So given mass of the solute divided by the molar mass of the solute multiply by the weight of the solvent. If it is not in the kgs, you have to uh, divide it by the 1000 term for the unit conversion from the grams to the kgs. So 20% aqueous solution of potassium iodide, what it means? It means that 20 gram, okay, 20 gram of potassium iodide is present in 80 gram solvent. So total we are taking about 100% solution, right? In that 100% solution, 20% aqueous solution of potassium iodide means that 20 grams of potassium iodide is present in the 80 gram of our solvent. Okay, consider solvent. Total gram of the solution is 100 grams. We have 20, in which we have 20 grams of potassium iodide and 80 grams of the solvent. Okay, this is the you can define, this is the definition, or this is the way to define the 20% mass by mass aqueous solution of any compound. Okay, so whatever percentage mass by mass is given, that will be the grams, that will be the weight of that compound in grams, and the rest of the 100 minus that, okay, 100 minus that weight will be the weight of the solvent, which will be the rest of the weight of the solvent. Okay, so 20 plus 80 grams will be 100 gram, 100 gram solution in which 20 gram potassium iodide is present in 80 gram of our solvent. So we simply put these given masses in our formula of the molality, which represents by small m. So the molality will be the given mass for the solute. The solute is 20 grams. The solute is potassium iodide. Solvent is something, okay, which is 80 grams. So the given mass of the solute is given as 20 grams. So 20 grams divided by the molar mass of the solute. When you talk about the molar mass of the potassium iodide, it is already given, which is 166 gram per mole. 20 divided by 166 multiply by 1000 divided by the weight of the solvent. Weight of solvent is 80 grams. So 80. Okay. And when you solve this fraction, this 0 will cancel out. And this will be 1000 upon 4 times 166. And when you solve that fraction, it will be equals to 1.506, which is approximately, you can write it as 1.51 mole per kg to, match the correct answer. So 1.51 mole per kg will be the final molality we determine from the 20% mass by mass aqueous solution of potassium iodide. Hence, the correct answer is option B. Okay. Okay, moving on to the next question. Okay. Now, this question is from the NCRT section 1.2 in the chapters solutions. And the question asks that a solution of sodium sulfate contains 92 gram of sodium ions, Na positive ions, per kilogram of water. The molality of sodium positive ions in that solution in the mole per kg is. So, we are talking about the solution of sodium sulfate, Na2SO4, okay, sodium sulfate, which is containing the 92 gram weight of sodium positive ions per kilogram of the solvent, which is water. Now, you have to tell the molality of the sodium positive ions in that solution in the mole per kg units. Okay. So, this question has been into the 2019 means examination. The four choices, the four options given are 12, 4, 132 or 16. Okay, so you have some time, go through it, so try to solve it, and then we can continue to the correct answer. Okay, so let's see. Okay, so for this given question, the correct answer is option B, which is 4. Using using the concept 7.7, we solve this question. So the number of moles of 92 gram of sodium positive ions. We have given the weight of sodium positive ions, right? We have given the weight of sodium positive ions, which is 92 grams. So if we have given the number of, if we have given the weight, we can identify the number of moles because we know the molar mass. Okay, the number of moles is defined by the given mass upon the molar mass. Okay, and if you know the given mass, you can, and you know the molar mass, you can easily determine the number of moles. Okay, so number of moles in given mass for the sodium positive ions will be the given mass, which is 92 grams, divided by the 23. 23 is molar mass for the sodium, or you can say atomic mass for the sodium. Okay, it will be equal to, this fraction will be equals to 4 moles. Okay, so the number of moles present in the 92 gram of sodium positive ions is 4 moles of sodium positive ions. Now, you have to identify the molality of sodium positive ions. So, molality is defined by the number of moles of the solute divided by the mass of the solvent in the kg units. This is the equation 1.9 given in our NCRT textbook. So the molality you have to tell about, you have to tell the molality of Na positive ion, sodium positive ion. So number of moles will be, we just have calculated, which is 4. So we put the 4 here in the numerator and divided by the mass of the solvent. So the molality will be equal to the number of moles of solute is 4 divided by the mass of solvent in the kgs is 1. So the molality will be 4 moles per kg. Okay, because it is already given in the question that the solution of sodium sulfate is containing this much amount of sodium positive ions per kilogram of water. Okay, so like for 1 kilogram of water, or you can say for 1 kilogram weight of the solvent, the number of the given mass of the solute is 92 grams. Okay, so we just identify that in that particular amount of the sodium positive ion given, what will be the number of moles for the sodium positive ions, and then what will be the molality. Molality will be simply number of moles divided by the mass of solvent. Now this much amount of number of moles is present in 92 grams of sodium positive ion, which is the given mass per kilogram of water. So mass of solvent will be 1 kilogram. So the molality will be 4 by 1, and this will be equals to 4 mole per kg. Hence, our correct answer is option B, that is 4. Okay. Okay, let's move on to the next question. This question is also has been taken from the NCRT section 1.2 in the solution chapter. The question has assertions and reason. Given below are two statements. One is labeled as assertion and the other is labeled as reason. The assertion statement is at 10 degrees Celsius, the density of 5 molar solution of potassium chloride, where the atomic mass of potassium and chlorine are 39 and 35.5 gram per mole respectively, is x gram per milliliter. Okay. Okay. So in the assertion statement, we have given at a particular temperature, we have given that the density of 5 molar concentration solution of KCl, the density is x, let's suppose x gram per milliliter. Okay. The solution is cooled to minus 21 degrees Celsius. So we change the temperature of the solution. The molality of the solution will remain unchanged, but the molality for this solution will remain unchanged. There will be no change in the molality. This is the statement assertion are telling us. Now the reason statement are is that the molality of a solution does not change with the temperature as the mass remains unaffected with the temperature. Okay, reason says that the molality terms of a solution will not change with the temperature because the mass is not can say change with the temperature, or it is mass is unaffected with the temperature. Okay, so these are the two statements, assertion and reason. In the light of the above statements, choose the correct answer from the options which is given below. So you have to tell that what will be the correct option or correct statement on the basis of the given two statements classified as assertion and reason. So this question has been into the 2022 mains examination, and the options are both A and R. So A is for assertion, R is for reason. Both A and R are true, and R is correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, but R is false. A is false, but R is true. So these are the four options. You have to select the one on the basis of assertion and reason statements given. So you have some time, go through it, think about it. After that, we will see that which option will be the correct answer. Okay, let's see. So for this given question, the correct answer is option A, that is both A and R are true, and R is the correct explanation of A. Okay, so this is the correct answer for this question. Now, using the concept 7.10, let's solve it. So, in the assertion, you have seen that molality, we are talking about molality. If you define the molality, which represents by small m, it is given by the number of moles divided by the mass of solvent in the kgs. Okay, and this molality equation is 1.9 equation in our NCRT textbook. So molality is defined by number of moles upon the mass of solvent in the kgs. You can see that the temperature term is not coming anywhere in the molality formula. Also, we are talking about the moles and the mass, and the mass is a thing, or is a quantity which will not change with the time, temperature, with the temperature specifically. So mass of any substance, mass is a constant thing. It will not change with the temperature. It will remain unaffected with the temperature. Molality of solution does not depends on the temperature. Why? As it depends on moles of the solute and mass of the solvent. Okay, moles of the solute and the mass of the solvent. Hence, both assertion and reason are true, and reason is correct explanation of assertion. Okay, so assertion is that at particular temperature, density of some 5 molar solution is given. When you change the temperature, when you cool down the temperature, or you can say when you cool down the solution, the molality will remain unchanged. This is said by the assertion statement. Now, reason said that the molality of a solution will not change with the temperature because the mass remains unaffected with temperature. And the assertion statement and reason statement both are correct in their own way. And also, the reason is the correct explanation of assertion. It is correctly, explaining the assertion statement. Right? Hence, our correct answer is option A. That is, both A and R are true, and R is the correct explanation of A. Okay. So, you can see that the concentration terms, basically, the concentration terms comes very much, or the question on the concentration terms is like coming in our J repeatedly. So, you have to consider these like molality, mole fraction, and volume by volume, mass by volume percentage, and all these concentration terms, pressure, volume. So you have to consider the questions on these topic more in the chapter solutions. Okay, it will cover the basic, the concentration terms questions will cover the base or the major part of the solutions chapter, right? Okay. Okay, thank you. This is all for the chemistry session, in which we have seen different MCQs in the which you can see in the JEE PYQ. Okay, in the JEE we have covered all the MCQs, and basically, if you want to try, you can also visit to our website, like Sathee website, and you can attempt there the mock test provided for the JEE, and you can also take the mock test. Okay, like uh, you can even take them, attend them, try to solve them, and then mark them, like whether you are doing right, or you can also, there are also solutions are provided, so you can also see that whether the solution is correct or not, or your solution is matching with that solution or not. You can practice as much as you can. All the recordings, all the lectures are present in that. If you want to see, I can show you. uh, okay, so this is our website, which is sathi.tutor.ai, and many of the students will is know already known about it, and if you don't, you can visit it and you can explore it. We have given various sections for the JEE, for the different examination. You can even attempt the different examinations. You can attempt the MCQs. You can see the recordings. You can see the question papers provided here. So simply, you can go here in the JEE term and the JEE section, and you can see that we have all the updated and the news and uh, the lectures and the mock tests and the your different class 12th, class 11th, 12th pass out, 9th and 10th, every kind of content is providing already on this website for you. Okay, you can consider visiting this website, explore it. You can enroll in these different, you can say, different courses. Okay, which is targeting different JEE mains for the years, for the next year, for the upcoming years. And you can also look at the recorded lectures, which is recorded by the IIT professors or subject experts from the subjects physics, chemistry, and mathematics. Okay, and this is basically the JEE Main 2025 target course for the preparation of JEE. Okay, from class 11th to 12th, and this is for the JEE Mains 2026, where the registration is open. You can clearly see. Okay, so you can explore our website, and you can also take the mock test here. And if you consider, So you can go here in the bottom and you can see we have different resources provided. Like for for the J, we have NCRT books, their solutions, their exemplar, and we have different resources for the physics, chemistry, and mathematics formulas and some useful articles. We have also the NCRT exemplar video solutions if you want. We have JE syllabus and the Sathi forum through which you can contact us and you can ask doubt. Okay, if you have any doubt, you can ask the doubt here in the Sathi forum. We have also JEE previous year questions and their tutorial sessions. Okay, so everything is available on our website. So kindly visit it, explore it, and then think you can consider it in your preparation as a part of it. Okay. Okay, so that's all for today's chemistry session. Thank you very much.